True or false? For x values greater than 0, the inequality arctangent x over the square root of the quantity x plus 5 is less than 2 over the square root of x. Okay, so we have to try to decide whether or not we think this is true or false. So let's start by thinking about arctangent x. And what do we know about arctangent x? So if I draw a quick little graph of arctangent, we know that it is bounded above by a horizontal asymptote at y equals pi over 2, and bounded below as well by y equals negative pi over 2. But basically an upper bound is going to be pi over 2. So let's start with arctangent x is definitely less than pi over 2 over its entire domain, but specifically for x values greater than 0. Okay, so pi over 2. What's the value of pi over 2 if we were to approximate it? Well, pi is about 3.14. So if I divide 3.14 by 2, it's about 1.57. So 1.57 is less than 2. So I can now establish that arctangent x is less than 2. And that's the numerator of my current inequality that I'm trying to decide whether or not it's true or false. So we know that arctan x is less than 2. Now we have to figure out how to involve these denominators. We want to show that this quotient is potentially true. So let's go ahead and think about the square root of x plus 5 and how that's always going to end up being positive. We're only plugging in numbers greater than 0, so this quantity is always positive. Now that's important because what I'm about to do is divide both sides of this known inequality. So we know for sure this is true. We reasoned our way through that. If we have a true inequality and we divide both sides by a positive number, or a positive quantity in this case, it's still going to hold. The inequality will still be true. So I can divide both sides by the square root of x plus 5. So let's think about it with numbers for a second, just to really help us understand that this is true. So if I have a known inequality, 3 is less than 7. And then I go ahead and divide both sides by the same number. That is a positive quantity. 3 divided by 10 and 7 divided by 10. Is the inequality still true? Yeah, so 3 out of 10 is less than 7 out of 10. But if those quantities were negative, that would change things, right? So it was important that these quantities will always be positive for any x greater than 0. Okay, so we're getting there, right? We're getting there to potentially show this is a true statement. So what we really wanted to show is that arctangent x over the square root of x plus 5 is less than 2 over rad x, not 2 over radical the quantity x plus 5. So now here's what we want to know. Is this true? Can we add an extra less than 2 over rad x question mark, right? Is this true? So basically let's think about these two compared with each other. So is 2 over the square root of x plus 5 less than 2 over the square root of x? So this one has a bigger denominator. So if they have the same numerator, but this one has a bigger denominator. So if a set of fractions has the same numerator, but one has a bigger denominator, that's an overall smaller number. So I'm taking 2 out of more. So that's going to end up being a smaller piece. So if I think about this in fractions with pizza, if I have a pizza that's only split into 4 and I take 2 pieces, right? But if I have a pizza and I split it into 8, bigger denominator, and I only take 2, that's less. So overall, this is a smaller fraction than this one. So bigger denominator, smaller fraction, as long as the numerators are the same. So yes, this is true. So that means that arctangent x over the square root of x plus 5, that is less than 2 over the square root of x, as long as x values are greater than 0. So let's make sure we go ahead and say that the answer here is true.